Hey everybody, this is Rob Guilfoyle of FW Web. This will be part one in a programming video series using Johnson Controls Controller Configuration Tool CCT13.1. In today's video, we will be creating a VAV or Variable Air Volume Air Handling Unit, and in subsequent videos, we will create the VAV boxes themselves. So to get started, we will go to File, New. You'll see where we have a new System Select Release Mode box that pops up. We can either be using 10.2 firmware or 10.4 firmware, and you'll notice that the selections of the types of controllers changes depending on which firmware you select. So for our purposes, we're going to select a 10.2 firmware because this program will be getting put into a PCG 2611 controller. So we'll say OK. Now this is going to be an air handling unit, mixed air single duct, system of units Imperial. We'll call this AHU01 for a system name. Say OK. Now we're going to need, for a supply fan, a variable speed fan. We're going to keep fan status. We'll skip over all the rest of that. No return fan, no relief fan. Economizer, we'll say that that is a common proportional mixed air damper output, and that our economizer suitability will be outdoor air, dry bulb temp economizer. We're going to reduce outdoor air on low temperature, which creates a mixed air sensor input. And if the outdoor air damper is open far enough that the mixed air sensor drops down below a predetermined value, then the outdoor air dampers will start to close back down again so that it doesn't provide too cold air and trip a freeze stat. Our temperature control strategy will be zone or return control. And if we expand that, we can select discharge air temperature reset by zone or return. And we're going to leave it as a zone temperature sensor to do the discharge air reset. We're going to scroll down further. We're going to select for occupancy control, scheduled occupancy with override support. We're going to select intermittent night operation for our unoccupied strategy. For our coils, we will deselect the preheat coil, and then I'm going to minimize that to get all those selections out of the way. For cooling, I'm going to say that we're going to use staged cooling. The cooling will be locked out from outdoor air. I'm going to expand the staged cooling and select 2 stages of cooling. Now we'll scroll down, reheat. So for our reheat coil, I'm going to say it's a hot water or steam, proportional output, and I'm also going to lock that out from outdoor air. As we scroll down, I'm going to say that we have a discharge air smoke detector. So I'm going to select our smoke control support under optional features, and then go to the next page. We're going to have an onboard outdoor air temperature sensor, so I'll select that. You can see our mixed air temperature has already been selected, so that's grayed out. Discharge air has already been selected. Zone temperature has been selected. And then if I scroll down here, I said I would use a discharge air smoke detector. So under monitored safeties, I'll go to discharge smoke detector, select that. Our low limit temperature switch has already been selected for us. So I'll click on finish. Okay, so the program has been built in the background. And here are all of our inputs and our outputs. Okay, so the first thing that we need to do is examine some of our connections. So I'm going to go down to our features on the bottom and select connections. I'm going to select our smoke control sequencing. And if you look closely, you can see that only one safety switch has been connected. So on our smoke control sequencing block, our inputs on the left-hand side, outputs on the right-hand side, only our low temp alarm switch has been connected. So I'm going to go to our safety switch 2 input, right click, make connection, and pick my discharge air smoke detector. Say OK. So now I've got both of my safety switches connected to my shutdown block. And what I also need to do is, if you look at the shutdown delay, you can see that it's set to 180 seconds, which for my purposes is too long. So I'm going to go up to Smoke Control Sequencing, right click, go to View Details, going to go into Edit Mode, go down to the 180 seconds, change that to 5 seconds. I'll click Apply, and then Close. Now 5 seconds is my new delay time, so if either one of those shutdown switches makes, the unit will shut down within 5 seconds. The next thing I want to look at is cascaded discharge air set point determination under output control. I need to change some of the set points here so that it's more reflective of a VAV air handler than a single zone air handler. So again, I can open this block up for editing by either right-clicking or double-clicking. Go into Edit Mode. And what I'm looking for is the discharge air reset set points. So for our cooling minimum set point, 55 degrees is fine. For our heating maximum, because the VAV boxes will be partially responsible for making sure that the zone temperatures are maintained, I can change this. So discharge air heating max, I can change to 70 degrees. And then our satisfied set point, somewhere in between our cooling min and heating max, I'll just call it 65 degrees. And I'll click Apply. So now these set points are more representative of a VAV air handling unit. Now the next thing that we're looking at here is that there's just a single zone temperature sensor feeding into this reset. What I'd like to do is take a look at the average of my VAV box temperatures, and you can select which VAV boxes you want to add to that average. I would suggest taking a sampling of different VAV boxes, some perimeter, some interior, just so that you get a decent average. You don't necessarily need to get all of them, just a decent spread around the space that is representative of the average of all of the spaces. So to do that, we'll go up to network inputs. I want to create 2 new network inputs because I'm going to eventually be creating 2 VAV boxes. Obviously, you would normally have more than that. For our purposes, I'll just do 2 just so you can see how it's done. So I'll go to plus, and I want to add 2 floating inputs. So I'll say 2. Those will be zone temp sensors. So I'll say ZN-T and finish. And now you can see down at the bottom here, I've got 2 new inputs, zone temp 1, zone temp 2. Now to do an average on these, I need to create an activity that will average those 2 temperatures. So I'll go under set point miscellaneous. I'll hit the plus, and in the filter I can type in ACT to bring me down to activity block, because that's what I want to add, and I will call it average zone temps. So now that I've got that created, I can right click on it. I'll go to View Logic, and I need to add some inputs. So since I've got two sensors that I'm going to be averaging, I'll bring in a floating input. I'm going to right click on this and rename it. I'll call it zone temp 1. And I can right click on this and do a duplicate to make a second one. You'll notice it's named zone temp 1 as well. So I'm going to right click on that, rename, change that to zone temp 2. Okay, now we need a means to average those two temperatures. So scroll down on the palette, find our way to statistical, choose an average block, drag and drop it into our workspace, and make our two connections. Now we're going to get an average of those two sensor inputs. And what I need is an output. So I'll go to Activity Outputs. Again, it'll be floating, drag and drop. I can right click on this and rename it. Average temp. Make my connection here. Now, when you're in commissioning mode, you'll want to see what this value is when you're back out in the control section. So what I can do to accomplish that is I will select our default element and select average temperature. So now when I'm in commissioning mode, or if I'm simulating, I'll be able to see that right on the block. So now we need to make connections to this to make it work the way we want. So I'm going to right click on zone temp 1, make connection, and I'll go down the list here to my network inputs and select zone temp 1. Now for zone temp 2, again, right click, make connection. I'm going to scroll down, go to our network inputs section, zone temp 2, select. Now I need to connect this average temperature to all of the places where currently our zone temp is connected. So if I select on the zone temp input, I can see on the output side, again, it's on the right-hand side of the block, these are all the different blocks that the zone temperature is currently connected to. So I want to change all of those connections. So the first one is cascaded discharge area set point determination. I'll select cascaded discharge area set point determination under output control. Here is my zone temp connection. I want to replace that now with average temp, so I will right click on the process variable, select change connection. I'll go to set point miscellaneous. That is where the average zone temp block is. Select it. Average temp is what I want to connect to that. And I'll say OK. Now if I go back to my zone temp input, I can see now there's only two connections to that. So this next one to do would be DA-T UNOC status determination V100. So I've got to find that. I happen to know it's under the state generation column. So I will select the state generation column and DAT UNOC status determination V100. ZN-T is under the zone temperature connection. I'll right click on that, change the connection. Again, go down to set point miscellaneous, average zone temp, select the average temperature, OK. Now you can see I've got a new connection there. I'll go back over to zone temp again. Now we only have one connection remaining to make that change to. Zone sequencing V51, state generation column, zone sequencing V51. Right click, change the connection. Scroll down, set point miscellaneous, average zone temps, average temperature to make the connection. Now if I go back over to my zone temp sensor, you can see it's no longer connected to anything at all. I don't need that zone temp sensor any longer. I just wanted it for connections for the program. So I can right click on the zone temp sensor and select delete. And then also there's another connection for that zone net sensor is AUX mode. We won't be needing that either. If I right click on that, I can also select delete. Okay, now my zone temp sensor is no longer connected. So I can go to define hardware. Now in define hardware, I have to tell the program what type of a controller I'm going to be using. So we said that we were going to be using a CCT13.1 controller. If I go to select and I go down the list, I find a CCT13.1 or 26XX, it could be a 2621 as well, and say OK. Device name, that's fine. Now down at the bottom, everything is green, so that means that I have enough analog inputs, binary inputs, analog outputs, and binary outputs to cover the selection that I've made previously. So I'm going to go to point assignment and take a look at all of my points here. If there was anything that you needed to shuffle around, you could do that here. If you wanted to move, say, the supply fan output and mixed air damper, if you did your drawings previously and they don't come up in the right spot, you can drag and drop, and then drag and drop. If you were in a situation where you didn't have enough room to move things to another location, you can highlight something to move it out of the way, hit the left arrow to unassign that point. Now you have room to move things into that position, and once you get things the way you want them, then you can select this and reassign that point, and it will come in somewhere. So as long as the points are in the order that you like, that's fine. We're going to go next to network settings. So on my BACnet network, my network number for this particular instance, I usually start at 2001 and then work my way up. So if I had a second BACnet connection, it would be 2002, a third, 2003, etc. So for my instance numbers, my device address for this particular controller is fine. I'm going to leave it at 4. I want that to be the lowest address on this BACnet network. And then my instance number would be a combination of network number plus device address. So for me, it would be 2001-04. Now for doing peer-to-peer, I want to go into advanced here and select the communication speed. By default, these controllers are auto baud, but since I'm doing peer-to-peer, I want something to determine what the communication speed will be for my BACnet network in case my supervisory controller went offline or something like that. So I'll go to advanced here and go to the baud rate, and instead of auto on this one, I'm going to choose 38,400. Go to close. Now I'll go back, say close that. And I need to do a little bit of housekeeping here. So for the peer-to-peer settings for my zone sensor inputs, I'm going to open and edit these before I leave the program. So I'll go into zone temperature 1. I'm going to right click on that and go to view details. Go to edit. So this zone temp 1 is actually going to be my VAV 01 ZN-T. And since we said that the air handling unit controller will be at device ID 2001-04. It stands to reason that this will be the next one in line, so this one's device ID is going to be 2001-05. So I'm going to go to my peer-to-peer reference. The device instance number will be 2001-05. And I happen to know for the zone temperature input that its backoid or object identifier is AI and 1106 for zone temp. So if you go through the system tree and do the question and answer, the zone temp sensor will come in as analog input 1106. Our default value, I want to make that something in the middle of our settings so that it doesn't affect if we're offline. So I'll say that will be 70. And for our units, we're going to select degrees Fahrenheit and apply. Our next one, same thing. So we'll go to View Details, Edit. This will be VAV02ZNT. Default value, 70. Units, degrees Fahrenheit. Device, be the next one in line, so that'll be 2001-06. And again, our object identifier, analog input, 1106. Apply and close. So that concludes this video on creating the VAV air handling unit. Subsequent video will go over how to configure the VAV boxes themselves.